How's it work? This is a high voltage circuit breaker. This is the bus here. The power comes from the bus and it goes out to the line. Sometimes it can go either way between two breakers on two different buses so that it can be fed from either direction. But the way this works is that these bushings are insulated. The power comes in here, 3 phases on one side, 3 phases on the other side. There's contacts inside. The contacts part. This whole tank is filled full of oil, and inside when they part, oil is actually sort of pushed between the contacts to blow out the arc inside this insulating oil, which allows the electricity to be in here without contacting different phases. It can be closer because of the insulation value of the oil. So the whole point of this thing is to work no matter what. The purpose of this is to break an arc, just like the circuit breaker inside your panel. If something happens, power needs to be interrupted. The whole design of this thing is to break current. That's its purpose in life. It makes current, but that's secondary to breaking current. So the way these are designed is inside here, this mechanism, this thing charges. And so right now the breaker's closed, and you can tell because there's an indicator there with a semaphore showing it in the closed position. There's a motor that charges these springs. It turns the cog, it charges the springs, and these springs have stored power. These are the closing springs. There's 2 sets. When this spring discharges, when it's commanded, it will close the breaker. But how can it do that right now? It's already closed. So inside the back of this, what's called the tail spring, are the trip springs. The trip springs trip the breaker, causing it to open. So right now, with these springs charged and those springs charged, in the closed position, it has a trip, and then it has a close, which will charge this trip spring when it closes, and it has one more trip. That way there's enough stored power to operate it. Now, these need to operate no matter what. So the power, this is designed if there's no AC power. The control power that operates this is actually by DC power. And there's a DC power source that is charged, but it's a battery, so that in the loss and the absence of power, that DC power will still work in order to operate this from commands that it receives based on things that happen and what it needs to do. So that control power is there even if the AC power is gone in order to charge it, and it can still operate. And then in a worst case scenario, with everything gone and everything absent, that trip spring is the last thing to be charged, and that can the mechanism can be physically collapsed for that to open the breaker to break current if necessary. That's how this works. Now this is an old oil-filled breaker. The newer ones don't typically use oil anymore, so this is probably a 1960s or 70s vintage. It used to have PCBs, but it's been retro-filled. It's just mineral oil in here, so it's actually pretty neutral because the oil is capturable. If you look around the yard, there's a rim that could catch oil if it's spilled, so it can't get out of here, and it can be contained. These are pretty reliable breakers, I would say. I mean, we're talking what, 50, 60 years, and they're still very reliable and easily serviceable.